Okay, so yesterday we talked about the power rule, and today we're going to take that power rule, do a little bit more with it. But before we do that, we're also going to learn about the derivatives of sine x and of cosine of x. Now, this whole section here in your notes, I really do not care if you take notes on this or if you just watch. You're never, ever, ever going to have to do this on your own. Okay, this is essentially like the proof of why it works. So if you take a college class, a lot of times your professors are going to do tons and tons and tons of proofs in math. They're just going to show you why things work, but you never actually have to use them. It's just more important for like the higher levels of math. So I want to expose you to why this works, but again, you're never going to have to know it. You're just going to have to memorize the answer. So all you're going to have to memorize, if you want to kind of skip the next couple minutes of the video and just realize like, hey, this is all I have to memorize, is that, again, this was meaning the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x. That's all you have to memorize, right? Like if f of x was equal to sine of x, and they ask, what is the derivative? Well, the derivative is just cosine of x. You just have to memorize that. But if you want to know why, okay, the reason why has to do with our identities, our trigonometric identities. So one of them, remember, was like that Pythagorean identity that I said was the most important one. Sine squared of x plus cosine squared of x equals 1. Well, other ones are these addition identities. So the cosine of a plus b of like two different variables or terms is cosine of a times cosine of b minus sine of a minus sine of b. You might have learned that in Math 3. If you didn't, no worries. If you ever really have to use identities, you can just look them up for the most part in calc. The only one that really ever appears on our exam is that one. So for the most part, they're just to help us understand why the math is the way it is. So basically, long story short, this is showing, that's our definition of a derivative. So anytime we're trying to prove why a derivative works the way it does, we're going to always go back to that definition. Again, on the AP exam, you can use the shortcuts. So on the AP exam, if I ask you what's the derivative of sine of x, we're just going to memorize its cosine of x. But to show why, we're going to use this rule. So this is going to be the limit as h approaches 0 of sine of x plus h minus sine of x, all divided by h. Now, for sine of x plus h, we're going to use that identity that I showed above. So that identity is, right, sine of a times cosine of b, right there. So instead of a and b, we have x and h. So this is going to be sine of x times cosine of h plus cosine of x times sine of times sine of h minus sine of x, all divided by h. Now in math, and again, this is not something I ever expect you to do on your own, but you can always rewrite the order of things. So I'm going to rewrite the sine of x first. And the reason for that is I noticed that both of those two terms have a sine of x in them. And so we could factor that part out. So, right, we have a sine of x and a sine of x, so we can factor that out. And so you'll see why in a minute. Again, we're just proving why the answer is cosine of x. So sine of x times cosine of h minus 1 plus cosine of x sine of h, all divided by h. And the reason we did that is, part of the reason is because this plus sign. So when we have that plus sign, right, when we were working on limits, we can just separate them. So this is sine of x times cosine of h minus 1 all over h, and then plus the limit as h approaches 0 of cosine of x times sine h over h. And so the reason I did this is back last chapter, we had two limits that we memorized. We had the limit with trig as x approaches 0 of sine x over x, that was equal to 1. And we had the limit as x approaches 0 of 1 minus cosine of x over x, that was 0. Now you can always flip these, so we could have the limit as x approaches 0 of cosine of x minus 1 over x, that's also 0. So we're going to kind of see those here. Okay, we're going to see that we have cosine of h minus 1 over h. That's this. Right now it's with an h, but it's also as h approaches 0, so it works. So this whole thing that I just highlighted is going to become 0. So when we plug in h, when we take the limit, essentially, this is going to become sine of x times 0. And then plus, now same thing here, right? We have cosine, let's see if blue works for highlighting. It's a little dark. So we have, just stick with the yellow. We have the sine h over h, right? That's sine x over x, that's 1. So this becomes cosine of x times 1. Okay. Right, so now this is 0 plus the cosine of x, which is just equal to the cosine of x. So now, that whole entire process was for our derivative, so we're just going to memorize that the derivative is cosine of x. For the sine of x1, I kind of went through it step by step with you guys. For the cosine of x1, because like I said, this is not something that I ever care about you having to do on your own. You don't have to memorize this process. You don't have to know this process. It's just showing you the why it works. All you have to memorize is the answer. So I'm going to kind of go through this very quickly for this one. So if you want to go ahead and just like pause this video and copy this down, you can. If you don't want to put in your notes, I really don't care. But the first step I did was, we took this and we rewrote it with the trig identity. Then the next step is, we see a cosine of x in both of these terms. So I factored out a cosine of x, and we're left with cosine of h minus 1, right? Kind of that rewriting it thing. And we split these up. The limit of cosine of h minus 1 over h as h approaches 0 is 0. And the limit of the sine h over h part is 1. And so that's why we get our answer of negative sine of x. So again, I'm not going to spend too much time on that. You don't have to put in your notes. If you want to, rewind it a little bit and just pause it. So now we're going to just kind of take what we did on yesterday, and we're going to just take it up a notch. So we're going to look at the equation of a tangent line again. Now, anytime we see equation of a tangent line, we always start off with x1, y1, and m. So our x1 here is negative 1. For our y1, we always plug that into the original. So always just going to remember y1 is always plugged into our original, into our f of x. So we're going to take, x equals 1, plug that in. F of negative 1 equals, 2 times negative 1 minus 1 times negative 1 plus 1 squared. This goes to 0. So anything, 0 times anything is 0. Okay, and then for m, we always plug this into f prime of x. So before we can ever plug it in, we need to first find f prime of x. So we can't plug in, like m is essentially going to be f prime of negative 1, but this is just very important. Before we can ever do f prime of negative 1, we first need to find f prime of x. So that's always really important. So now, before we can find f prime of x, we need to, rewrite this in polynomial form. So I'm going to FOIL out 2x minus 1 times x squared plus 2x plus 1, right? That's from, x plus 1 times x plus 1, we FOIL that out. Or you can do the shortcut, square the first, multiply together times 2, square the second. And I'm going to do this the way that I showed you guys yesterday in class, which was just writing it out kind of like a long multiplication. So negative 1 times negative 1 is negative 1, or negative 1 times 1 is negative 1, negative 1 times 2x is negative 2x, negative 1 times x squared is negative x squared. These were all positive. I don't know where I got the negatives from. Okay, and then 2x times 1 is 2x, 2x times 1 is 4x squared, and 2x times x squared is 2x cubed. So now we have this, and we're going to just kind of add up our like terms. We get 2x cubed. Yeah, we did have negative 1. I don't know what I'm doing today, guys. I'm so sorry. I was looking at the wrong thing. So yeah, this is 2x minus 1. Okay, so this is negative 1, negative 2x, and negative x squared. So we get 2x cubed plus 4x squared minus x squared, right, is 3x squared. These guys cancel, and then minus 1. So this is what f of x was, not what f prime of x, but what f of x was. So now to take the derivative, we're going to do f prime of x, do that power rule. 6x squared plus 6x, the derivative of the negative 1 just goes to 0. Don't put minus 1, that went away. So now for m, right, how do we find m? M is f prime of negative 1, right? We're plugging in negative 1 to f prime. So 6 times negative 1 squared is 6. 6 times negative 1 is minus 6, and we get 0. So that's what our m was. So now that we have that, now we can just do our point slope form. So y minus 0 equals 0 times x minus 1 minus negative 1 plus 1. And you could rewrite this as, basically y minus 0 equals 0. So just basically y equals 0, which essentially that is the x-axis. So now same thing, but for something with trig in it. Now theta is just like an x. So when you see theta, just treat it like it was x. So you can still write x1, y1, and m. And our x1 is pi over 2. For y1, we're going to plug in, right? So f of pi over 2 equals 4 times sine of pi over 2 minus pi over 2. Now, pi over 2 on our unit circle is up here. Sine of pi over 2 is 1. So this is 4 times 1 minus pi over 2. So our answer there, we can literally just write that as 4 minus pi over 2. We don't have to worry about simplifying. I'm just going to write this as 4 minus pi over 2. Okay. And for m, before we can do m, we need to first do f prime of x. So f prime of x, we memorize the derivative of sine is cosine. So for cosine of theta, minus, now this is just like an x. So the derivative of x would be 1. So this is minus 1. So now for m, that's going to be plugging in pi over 2. So we're going to get 4 cosine of pi over 2 minus 1. And the cosine of pi over 2 up here is 0. So that's 0 minus 1 is negative 1. So now we're going to write y minus 4 minus pi over 2 in parentheses like that equals negative 1 times x minus pi over 2. And this can be our answer. If we want to distribute, we can make that y minus 4 plus pi over 2 equals negative 1 times x minus pi over 2. We can write it like that as well. Distribute that negative. So same thing, we're just going to do it twice more. I'll try to do these a little faster. So x1 is pi. y1 we're going to plug in. So that's 2 pi plus, now the cosine of pi, right, pi's over here, is negative 1. So that's 2 pi, and then, right, 3 times negative 1. Right, so is negative 3. So this is going to be 2 pi minus 3. And for m, we're going to take the derivative. So g prime of x, we're going to do that first, is 2. And the derivative of cosine is negative sine. Now the 3 is just going to kind of hang out in front. So 3, sine x, or sine theta. So the derivative of cosine gave us the negative sine. So this is like the derivative is 3 times negative sine theta. I just moved the negative to the front to make it minus 3 sine theta. So now for the m, we're going to plug in just pi. So 2 minus 3 sine of pi. And sine of pi goes to 0. So the m is just 2. Okay. So now with this guy, now we have y minus 2 pi minus 3 in parentheses, right? Or you can distribute and make it y minus 2 pi plus 3 equals 2 times x minus pi. All right, and then this last one, we have to worry about the whole rewriting thing. But first, let's just put in our x1, our y1, and our m. So x1 is 2. y1 we plug in 2x over the the square root of 2 cubed. 2 times 2, we're plugging in 2. So we get 4 over the cube root of 8. And that's okay. We're just going to write our answer just like that. Okay, so 4 over the cube root of 8. And for m, we need to rewrite this. So h of x equals 2x over, we're going to write this as x to the 3/2 power, right? The inside is on top, the outside is in the denominator. And so now this is going to become h of x equals, I can write this as 2x to the 2 over 2 over x to the 3 over 2. So we're getting rid of 2 of them. So we're going to get rid of 2 of them, and that's going to become the 1/2. So this is h of x equals 2 over x to the 1/2. And now we're going to bring that to the numerator and make that 2x to the -1/2. Okay, so now it's a little tricky, but hopefully we learned this yesterday. Now, all we did was rewrite it. We haven't even taken the derivative. So when we take the derivative, we get -1/2 times 2 is -1, x to the -3/2. Okay, and then we're going to plug in 2, right? Now, before I do that, I'm going to write this as -1 over x to the 3/2. And we can write this as -1 over the square root of x cubed, right? The inside is the 3, and the outside is the 2. So we're going to kind of do our m off on the side. So m is equal to, we're going to plug in 2. So the square root of 2 cubed. And so we get that as -1 over the square root of 8. And again, we can just write that here, -1 over the square root of 8. So I'm going to go ahead and just do y minus 4 over cube root of 8 equals -1 over, and then I don't know where I got the cube root. It was just square root, right? There was never a cube root here. It was just square root. So that's my fault. So y minus 4 over square root of 8 equals -1 over square root of 8 times x minus 2. Okay. So just be careful if you were following along. Make sure there wasn't ever a cube root, so get rid of that cube root. But there's that process. Okay. So kind of going here, given the equation of a function, how might you determine at which values the function has a horizontal tangent? So kind of a reminder about horizontal tangents is horizontal tangents would be tangents that are horizontal. Very easy, right? So what do we know about a horizontal tangent? We know that the slope there is 0. So we kind of know that our horizontal tangents, now they occur at maximums or minimums, but the main thing that we want to make sure that we know is whenever we see a horizontal tangent here, that's when f prime of x equals 0. Our slope is 0. So our explanation can just kind of be our graph. So whenever something says at what values does a function have a horizontal tangent, or whenever we see a horizontal tangent, we want to be thinking that m is 0. So we're still going to do x1, y1, and m because that's our process when we see the word tangent. But instead of here, in these questions, they always gave us an x value, right? They said when x equals 2. Here, instead, we don't have an x value, but we saw the word horizontal tangent, so we know that the slope is 0. So this is going to kind of be like working backwards. So what we're going to do first is we're going to first take the derivative, right? The derivative of this is 3x squared plus 1, but we're going to set that to 0. Why are we setting it to 0? Because it's a horizontal tangent. So now if we subtract 1, -1 equals 3x squared, divide by 3, -1/3 equals x squared. To solve, we're going to take the square root of both sides. So the square root of -1/3, right? We're going to put a plus or minus in front. But we cannot take the square root of a negative, right? In calculus, I told you guys the square root of a negative is d/n(e). So when we see this, it's kind of no solution, right? So whenever we have a square root of a negative, our answer is no solution. So what we can kind of say is that essentially that our answer is at what values? Well, there's no solution. There are no values of x. Okay. Now let's do the same thing, but with a trig. So again, x1, y1, and m. Okay, so our first step is we see that we have horizontal tangent, so our m is 0. So we're going to do f prime of x equals, or really f prime of theta, I guess, equals, now the derivative of theta is 1. The derivative of sine is cosine of theta. So 1 plus cosine of theta. So we're going to set this to 0 because that was our m. Subtract 1 from both sides. And then the process of this is essentially, we're taking the inverse cosine of both. But what that's asking us is, where is the cosine, where's the value of cosine -1, right? So you could use your chart, you can use your unit circle, but where is the answer of the cosine of theta -1? And it's at pi. So pi is our answer to theta. So now that's our answer. At what values? Well, at pi. All right, now if we were going to have to actually write the whole equation, and we put pi in here, we'd plug it into the original to get the y, and then we could write the equation. But it didn't ask us to write the equation, it just said where. So our answer for where is at pi. Okay. So we're going to do the homework in class tomorrow. Email me if you have any questions before then, and I will see you guys in class.